Okay, question number 1. E to power integral e to power 5x cosine 3x dx. Okay, so first of all we need to find substitution by parts. So remember in my previous or the video before, I don't remember, in one of these videos, the integral by part, we did which templates we use for integral by parts. So and e to power ax cosine bx is one of them. So u is equal e to power 5x, and accordingly du will be 5 e to power 5x and dx. Yes? And dv that is given is cosine 3x dx. This is dv, this is u. And if I take integral for v, it's going to be dv, which is going to be cosine 3x dx, and that is going to be 1/3 of sine 3x. I already previously have explained in previous videos why we get 1/3, because you do substitution of 3x and it's coming from there. If you do cosine 3x to substitution u, you will see it will come out 1/3. Okay, so we are going to follow again the rule integral u dv is equal uv minus integral v du. All right, so what do we have here? Integral e to power 5x cosine 3x dx is equal e to power 5x, my u, right, times v. V is going to be 1/3 sine 3x, right, and minus integral v, which is going to be 1/3 sine 3x, and du, which is going to be 5 e to power 5x dx. Okay, so let me mark down so you would know this is our u, this is our v, okay, this is our v, and this is our du. Okay, so this is going to be equal 1/3 e to power 5x sine 3x minus 5/3, right, we're taking constant out, integral sine 3x e to power 5x dx. So what do we have? Sine 3x and dx, it's going to be our dv, and e to power 5x is going to be our u here. So we are going to substitute again, and that's going to be u is equal e to power 5x, and dv is equal sine 3x dx. Accordingly, du is equal 5 e to power 5x dx, right? and v is going to be equal negative 1/3 cosine 3x, because integral of sine x is negative cosine x. That's why we get negative. Okay, so this is going to be equal 1/3 e to power 5x sine 3x minus 5/3 opening square brackets, and we are getting e to power 5x times negative 1/3 cosine 3x. Let me mark down, this is our u, this is our v. We're applying again uv minus v du. So minus integral negative 1/3 cosine 3x, and du, it's going to be 5 e to power 5x dx, right? So this is our v, and this is our du, right? What we are going to get here? So we are getting e to power 3x, e to power 5x this is what we get interesting. Let me show you which color to use so it will be seen. This color. Original problem was e to power 5x cosine 3x dx, and here we repeat it, so negative 1/3 will come out, and we get again cosine 3x 5 the e to power 5x dx. So negative the 5/3 will come out, so we get original one, right? Once we get we integrate, and we coming back to the starting point, which means integral cosine 3x and e to power 5x. Then we're gonna isolate these two and combine as a like terms. So this is what I am doing again. I am doing integral e to power 5x cosine 3x, that's the original one, writing down, plus, hold on, this is, let me see. What is gonna be happening? Okay, let me distribute. It's gonna be equal. Let me distribute, go slow. It's gonna be equal e to power 5x sine 3x divided by 3, right? First term, minus, rather saying it's gonna be plus, because I have here minus, and here also have minus, so it's gonna be plus, right? 5/9 e to power 5x cosine 3x. Next, minus 5/3 times 5/3. Where from I get negative minus? Here is I have one negative, another negative, and here also another negative. 3 negative, so we will end up with negative again, yes? 5/3 times 5/3 integral, this one 5/3 is this one, another 5/3 is this 1/3 times 5, yes? Let me clean, otherwise it's gonna look too messy. Okay, so minus 5/3 times 5/3 integral cosine 3x times e to power 5x dx. Okay, so look what we have, right? These two I'm going to combine. and I'm going to get integral e to power 5x cosine 3x dx plus 25 over 9 integral cosine 3x times e to power 5x dx, and that is equal e to power 5x sine 3x over 3 plus 5 over 9 e to power 5x cosine 3x. Okay, now when we combine, what's going to happen? Here we have 1 and plus 25 over 9. We are going to get, let me see, 34 over 9, right? We get 34 over 9 integral e to power 5x cosine 3x dx equal 1/3 e to power 5x sine 3x plus 5 over 9 e to power 5x and cosine 3x, right? Now all I have to do, divide the entire equation by 34 over 9. And from here we are going to get e to power 5x cosine 3x dx is equal 3 over 34 e to power, need to go slow so not to cause any questions. 1/3 divided by 34 over 9, which means we are flipping 9 over 34, right? Okay, and e to power 5x sine 3x plus 5 over 9 times 9 over 34 e to power 5x and cosine 3x. Okay, this 3 is gone with this 9 and we get 3 over 34, and this 9 is gone with this 9. And our clean answer, it's gonna look like e to power 5x cosine 3x dx is equal 3 over 34 e to power 5x sine 3x plus 5 over 34 e to power 5x cosine 3x. Okay, and this is our answer. All right, moving to next one. Question number 2. Integral sine degree 6x dx. I suggest interesting solution here. Integral sine square x. How much is it? Remember? Here is sine square x is equal 1 minus cosine 2x over 2, right? So we get 1 minus cosine 2x over 2 times 1 minus cosine 2x over 2 times 1 minus cosine 2x over 2 and dx, and each one of them is going to be sine square x, sine square x, sine square x, right? So together we're going to be sine to power 6x, right? All right, now what am I going to do? I'm going to multiply by each other, and this is what I'm going to get. integral, I'm going to get 1/4. So first I'm multiplying. Let me clean now this since we already know. Now we're going to next step. So let me show you. I am multiplying 1/2 time. Okay, maybe I should rewrite it. Okay, let me rewrite it so it would be easier for you to see, guys. So it's going to be 1/2 minus cosine 2x over 2 and 3 times 1/2 minus, so it would be easier to multiply because we are going to manipulate with this. I don't want to leave denominator and manipulate with numerator because I will need denominator also. That's why I'm separating. And dx. Okay. So it's gonna be, I'm multiplying first this and this, right? I'm getting 1/4 minus cosine 2x over 4 and minus cosine 2x over 4, right? Let me see. This is our 1/4. This is our cosine 2x over 2x. And now I'm moving to minus, oh, this one. Let me, oops. Changing color so you will know, minus cosine 2x and minus plus cosine squared 2x over 4. Okay, and times 1/2 minus cosine 2x over 2 dx. Let me clean this so this and this. Okay, next, equal. Oh, we have here like terms. Let's combine them. What we're gonna get, integral 1/4 minus 2 cosine 2x over 4, right? This is gonna be 1, this is gonna be 2, correct? Plus cosine squared 2x over 4, and then 1/2 minus cosine 2x over 2 dx. Yes? Okay, now let's multiply this also. What we're gonna get? 1/4 I'm multiplying by 1/2, and then I'm multiplying by cosine 2x, and I'm getting integral 1/8 minus cosine 2x over 8, right? Cleaning. Moving to next one. Multiply by 2, multiply by negative cosine 2x. It's going to be negative cosine 2x over 4, right? And plus cosine squared 2x over 4, right? Okay, cleaning this, and after that I'm multiplying this. It's gonna be plus cosine squared 2x over 8 and minus cosine cube 2x over 8, and all this gonna be dx. Okay, now let me go here. This comes here, This comes here, this color, and then with this color it comes here and comes here, so you can see. All right, all right. And lastly, what we can do here, what we can combine here, cosine square and cosine square x 2x and cosine square 2x, these two. Right? Okay. What am I going to get here? Integral 1/8. Oh, these two also. I have another two here. Okay. So what I'm getting here for this one, I'm multiplying for these two, I'm multiplying here by 2. Let me use different color because I already used, so it won't confuse you. Here it's gonna be 1 and 1, just for you see which one I'm multiplying, which combining with this one. Here is 2 and also 2, right? Now this color, for this one I will use black one, so we can see this is times 2, and this one is 1 and 1. So okay, we are getting here we are getting how much? 8 and 8, negative cosine 2x and negative 2 cosine 2x. It's going to be negative 3 over 8 cosine 2x, right? Next, plus 2 cosine square 2x and cosine square 2x. It's going to be 3 over 8 cosine square 2x and minus 1 over 8 cosine cubed 2x dx, right? Now we are going to separate them. So it's going to be integral 1 over 8 dx minus 3 over 8 integral cosine 2x dx plus 3 over 8 integral cosine squared 2x dx and minus 1 over 8 integral cosine cubed 2x dx. While I was writing all this, I thought, okay, I took everywhere constant. Why I didn't take it out here? Very good question. And I have no idea why I didn't take it out. I just left it there. But now I'm taking out. Okay. All right. So we are getting here, result is going to be 1 over 8x, integral dx is going to be x, right? And minus 3 over 8, since we have cosine 2x, it's going to be times 1 over 2 and sine 2x, right? Now with these two, we need to work with. So this is what I'm going to do. This is, I'm painting green color because I'm going to work this out. And this one, green color. And this one, I'm going to paint light blue color. And I'm going to work with them. So, yeah. Okay. So this is going to be minus b. This is going to be plus a. And I'm going to work out a and b separate, because these two is a separate story. So we have this piece ready. We leave it alone for now, and I'm going to work with piece part A and B. Okay, so let's start working. A is equal 3 over 8 cosine square 2x dx is equal 3 over 8 integral cosine squared to x. It's going to be 1 plus cosine 4x divided by 2, right? Let me write down cosine square x is equal 1 plus cosine 2x over 2. While here we had, where is it, sine, here it is, sine square x, 1 minus cosine 2x over 2, okay? And what we are getting here, let's work on this piece. So we are getting 3 over 8, okay, here is dx. You know what, let me move it so down this piece so it won't cause any question confusion. This will be much better. There we go. Okay, I'm going to separate, so it's gonna be integral 1/2 dx, and yet again I left it, that's okay, I'm going to take out anyway. So plus 3 over 8 integral cosine 4x over 2 dx. Okay, this is equal 3 over 16x, right? And plus 3 over 16. Okay, this 2 comes out also. It will be 3 over 16 and times, since we have cosine 4x, it's going to be 1 over 4 and sine 4x. Yes? So from here we are getting 3 over 16x plus 3 over 64 sine 4x. Okay, so this is answer for A. Okay, now let's go work out B. Our B was negative 1/8 cosine cubed 2x dx. Okay, so we have B negative 1/8 integral, was it cosine cube? Yes, cosine cubed 2x dx. Okay, this is equal negative 1 over 8 integral cosine squared 2x times cosine 2x dx. All right, so cosine squared 2x, I'm going to open up negative 1/8. It's going to be integral 1 minus sine square 2x. It's we are using cosine here. Let me write down. We are using sine square x plus cosine square x equal 1. So it doesn't matter cosine square 2x plus cosine square 2x. So cosine square 2x is equal 1 minus sine square 2x and times cosine 2x and dx. Why did I do that? Because it's easy when I start doing substitution here. So for substitution, it is going to be, I'm doing here substitution. My u, it's going to be sine 2x, and accordingly, du is going to be 2 cosine 2x dx. Don't be surprised why it's 2 and not 1/2, because this is derivative. When I'm taking 1/2, that's from under integral comes out 1/2, right? And we are going to have here, so negative 1 over 8, since we need here 2, right? See, so I'm multiplying here by 1/2 because I need to squeeze in 2 there, and it's going to be integral 1 minus sine squared 2x and multiply by 2. Let me write down this 2 so you will see where from it is. 2 cosine 2x dx. Okay? And we are getting negative 1 over 16 and sine 2x. I am substituting with u. Here it is. And I'm going to get, let me put this integral nicely. Okay, it's gonna get 1 minus u squared du, because 2 cosine 2x dx, it's my du, right? And I'm getting negative 1 over 16 separating du plus 1 over 16 integral u squared du. Beautiful. So we are getting negative 1 over 16 u, right? Comes out u, plus 1 over 16, it's going to be u cubed over 3. Yes? And the result is negative 1 over 16 sine 2x plus 1 over 16 times sine cubed 2x, because we have u cubed, over 3. So the answer for B is equal negative 1 over 16 sine 2x and plus 1 over 48 sine cubed 2x. Okay, now let's put all pieces together and we are going to get, so integral sine to power 6 dx is equal. Let me go back to see what we had. 1 over 8x minus 3 over 16 sine 2x. Okay. 1 over 8x minus 3 over 16 sine 2x, and then we are adding this our a, and which is 3 over 16x plus 3 over 64 sine 4x. So it's going to be plus 3 over 16x plus 3 over 64 sine 4x. Let me paint it in green color so you would know this is our A part. Okay, and now I'm moving to our B part. B part, which is gonna be minus, so you will know, 1 over 16 sine 2x and plus 1 over 48 sine cubed 2x. Okay, let me make it more compact so it will fit in one page. There we go. So let's see what we can combine. 1 over 8x, 3 over 16x. Anything else? Yes, negative 3 over 16 sine 2x, negative 1 over 16 sine 2x. And we are getting, if we combine, let's say this one, x and x, so common denominator 16, this is going to be times 2, and I am getting 2 plus this 2 plus this 3, right? I'm getting 5 over 16. Let me clean this. 5 over 16x, right? Next, 1 over 16, 1 over 16. There is nothing to combine. all I'm going to do, negative 3, negative 1, it's going to be negative 4 minus 4 sine 2x over 16, and I'm reducing, this is 1, this is 4, right? And the rest I'm rewriting, there is nothing else to do, plus 3 over 64 sine 4x, and minus plus 1 over 48 sine cubed 2x. So the plus c. Okay, actually here also I can't put plus c because it's all out. Okay, so this is here I can put plus c1. Well, okay, it's just part of it. Okay, so answer is 5 over 16x minus sine 2x over 4 plus 3 sine 4x over 64 and plus sine cubed 2x over 48. I'm going carefully so not to do silly mistake. Okay, and plus c. And I am done. Okay, so two long integrals, we solved it. I'm done with this video, and I'll see you next video. So I will start now solving using different method next time. Okie dokie.